Welcome to the types of alloys lesson. Alloys are typically a mixture between metals but they can also be sort of a non-metal. Interstitial alloys are going to be a lattice structure where there may be an atom that is larger than the respective atom. So one of the atoms is larger than the other, and so there's that little space in between in the lattice. And so this is sort of an example of an interstitial alloy. When we look at substitutional alloys, they're able to, again, substitute the different sizes. So there can be a different atom that has relatively the same size. So this would be a substitutional alloy in a diagram format or particle diagram format. And so the way you can identify if something is in an interstitial or substitutional alloy is based upon the molar masses of these components. So the molar mass of titanium is going to be around 47.9, and carbon is around 12. So you can kind of tell the differences between the molar mass, and you can see that it would be an interstitial alloy because of the big difference between molar mass. So that being said, the higher the difference in molar mass, it's going to be an interstitial alloy. And so in this next example, when we have steel, you have iron, which is around 55.8 grams. And then carbon is again around 12 grams for the molar mass. So steel would really be sort of this iron and this interstitial alloy with carbon. Carbon. So carbon, iron, carbon, iron, carbon. And so those are interstitial alloys. When we look at substitutional alloys, brass is CuZn. So copper is around 63.5. And then zinc is around 65.4. So these are incredibly similar in terms of their molar mass. So they would have around the same size, which means it would be a substitutional alloy. So Cu and zinc, so copper and zinc have relatively the same size. So that's known as a substitutional. And then last but not least, bronze. So again, copper is 63.5, around there. And we have tin, not zinc, tin. And tin is around 118.71. And so this would be an interstitial because you can't substitute such a value because it's so high. So Cu, and then Sn would be a bigger atom. in this particle diagram below. So again, Sn would be larger than Cu. And so that's sort of the input between the differences between interstitial alloys and substitutional alloys. You want to look at the differences between the molar mass of each of the elements in the alloy. So thank you so much for watching this video, and I'll see you in the next one.